Hi everyone, welcome to this video tutorial in which we are going to explain you about the spherical mirror, specifically about concave mirrors. Before going deeper into this topic, it is necessary to have knowledge about what we are talking about. So, let's start. What is a mirror? A mirror is an object that reflects light in such a way that, for incident light in some range of the wavelengths, the reflected light perceives many or most of the detailed physical characteristics of the original light, called specular reflection. This is different from other light reflecting objects that do not perceive much of the original wave signal other than color and diffuse reflected light such as flat white paint. What happens when light hits a mirror? When you stand in front of a mirror, what you see is the conversion of energy in action, working its magic on light. Light is energy traveling at high speed, 200,000 kilometers or 186 miles per second. When it hits an object, all the energy has to go somewhere. There are three things that happen when light hits something. It can pass through if the object is transparent, sink in and disappear if the object is opaque and darkly colored, or it can reflect it back again if the object is shiny, like color, and reflective. Either way, the conversion of energy is at work. There is just as much energy around before light hits something, as afterward, though some of the light may be converted in other forms. Types of mirrors. Shape of a mirror surface. A beam of light reflects off a mirror at an angle of reflection equal to its angle of incidence if the size of a mirror is much larger than the wavelength of light. That is, if the beam of light is shining on a mirror surface at a zero angle vertically, then it reflects from the point of incidence at a zero angle vertically in the opposite direction. This law mathematically follows from the interference of a plane wave on a flat boundary of much larger size than the wavelength. Here there are three examples of different types of mirrors. So I'm gonna explain each of them. The first one, in a plane mirror, a parallel beam of light changes its direction as a whole while still remaining a parallel. The images formed by a plane mirror are virtual images of the same size as the original object. In a concave mirror, parallel beams of a light become a convergent beam, whose rays intersect in the focus of the mirror, also known as a converging mirror. And the last one, in a convex mirror, parallel beams become divergent, with the rays appearing to diverge from a common point of the intersection behind the mirror. Spherical mirrors. A spherical mirror is a mirror which has the shape of a piece cut out of a spherical surface. There are two types of spherical mirrors, concave and convex. The most commonly occurring examples of concave mirrors are shaving mirrors and makeup mirrors. As well as well known, this type of mirrors magnify objects placed close to them. The most commonly occurring examples of convex mirrors are the passenger side wind mirrors of cars. These type of mirrors have wider fields of view than equivalent flat mirrors, but objects which appears in them generally look smaller and therefore farther away than they actually are. Let me now introduce a few key concepts which are needed to study image formation by a concave spherical mirror. The normal to center of the mirror is called the principal axis. The mirror is assumed to be rationally symmetric about this axis. Hence, we can represent a three-dimensional mirror in a two-dimensional diagram without loss of generality. The point B at which the principal axis touches the surface of the mirror is called the vertex. The point C on the principal axis, which is equidistant from all points on the reflecting surface of the mirror, is called the center of curvature. The distance along the principal axis from point C to point B is called the radius of curvature of the mirror and is denoted R. It is found experimentally that rays striking a concave mirror parallel to its principal axis and not too far away from this axis are reflected by the mirror such that they all pass through the same point F on the principal axis. The point which lies between the center of curvature and the vertex is called the focal point or focus of the mirror. The distance along the principal axis from the focus to the vertex is called the focal length of the mirror and is denoted by AF. Now you know all the concepts about spherical mirrors. Let's put them into practice with the following exercise. The problem says an object is placed 10 centimeters from a concave mirror. The focal length is 5 centimeters. Determine letter A, the image distance, and letter B, the magnification of the image. We have the data, that is the focal length is equal 5 centimeters and the object distance equal 10 centimeters. Here we have a small drawing in which you can identify the object in a concave mirror. First of all, we need to calculate the image distance that the formula says 1 over d equal 1 over f minus 1 over 2 equal 1 over 5 minus 1 over 10 equal 2 over 10 minus 1 over 10 equal 1 over 10. D equal 10 over 1, it's equal 10 centimeters. The distant image, the image distance is 10 centimeters. Now we need to calculate the magnification, which the formula says m equal minus d over 2 equal minus 10 over 10 equal minus 1. This result means that the image is the same as the object. The minus sign indicates that the image is inverted. If the sign is positive, then the image is upright. Well, this is all for us. Thank you for watching this video. I hope that you are enjoying it. I really appreciated your attention and see you in the next video. Thank you.